was separated into two phases, Phase 1 filtration and Phase 2 distillation. The contaminated water was first filtered to get rid of large particles. This is because the more impurities water has, the higher the boiling point will be. Thus, filtering will be helping speed up the distillation process. Distillation was used because it was deemed to be the most suitable method in removing salt and food coloring from water.
Phase 1. Filtration is a separation technique used to separate non-volatile molecules. The contaminated 1 liter of water was divided into half and filtered separately into 2 different filtration systems in order to speed up the process. Our filtration system consisted of 3 layers, a layer of big stones, followed by a layer of smaller stones, and finally a layer of fine sand. These layers were used to prevent large particles from the contaminated water from passing through. Each layer had cotton on top of it, which helped in absorbing the smaller particles and the dirty color. The reason the bases of the bottles were used was because it made it easier to remove and change the cotton while filtering. This also made it easy for when the filtering material had to be cleaned.
Phase 2. The filtrate was then poured into a pan, which was then covered and sealed with silicone and placed on a crisp pan with fuel to be burnt inside.
When heated, the steam evaporated up into the hoses and into the copper coil, which is in a container with soft drink and ice packs. The top of the container allows for the soft drink to be cycled, which adds to the cooling effect when the steam passes through the copper coils.
When it does, it loses heat and condenses into water, and then falls into the collection container. All of the impurities are left behind in the pan, thereby producing clean water. For the conductivity test, we constructed a simple circuit with an LED light that uses liquid to close it. The water acts as a variable resistor, changing resistance with respect to the varying impurities and their conductivity. This can be used to give an indication to how much salt is in the water, since the more ions that are in this water sample, the brighter the bulb would light.
Our pH tester was made from boiling red cabbage pieces in water until all the juices were drained out. This juice was then soaked in rectangular napkin pieces and dried to make a pH paper. This paper turns pink in acidic condition and green in basic conditions.
Our turbidity test was a simple construction of a circle that was sectioned off into 4 quarters, and 2 of the opposite sections were colored black. This is to be placed under a jar with the sample water and then looked at from above. How clearly the image can be seen will give an average on how many impurities are in the water.
Our goal was to create a visibly cleaner appearance in 1 liter of muddy water through filtering. It was constructed out of a 2-liter Coca-Cola bottle that was cut at the base. Then into it was added the same volume of coconut fiber, red sand, coarse sand, pebbles, and then stones. It was constructed this way because each layer would trap different sizes of particles while the dirty water moved downwards through it because of gravity. This prototype failed because the coconut fiber was not able to stop the red sand from passing through, and it ended up being present in the filtrate. What we learned was that red sand was not an appropriate medium to use in our filter.
What we did next was remove the red sand and keep the remaining materials to try another test. The results showed very little change in the quality of the water. From this, we learned that the coconut fiber did very little in the filtration process.
Our goal with this prototype was also to create a visible difference in the appearance in 1 liter of muddy water through filtering. It was made with the top of 3 2-liter Coca-Cola bottles, one with the base cut off. The individual tops were filled with coarse sand, pebbles, and stones, respectively. Then each top was placed one after the other into the bigger bottle in the order sand, pebbles, and then stones. Also, each layer was placed into a cut bottle top to become easier to remove after use. Despite filtering the water to a desirable quality, this model was time-consuming. From this, we realized that too much cloth can slow down the rate of filtration.
The goal of this prototype was to test a small design to find out how much cloth should be used. This prototype was made with the basis of 4 250 ml Dasani water bottles and cloth. It was hoped that by using the basis of the bottles, it would be easier to remove each section and change the cloth during the filtration. This is because the dirty cloth will not absorb as much dirt as the clean one. This model failed because the rate of filtration was slow, which caused the water to back up and overflow out of the filter at the last level. This taught us that small containers were not suited for the rate of filtration we needed.
The goal of this prototype was to create a distillation system to remove the salt, vinegar, food coloring, and all the dirt from the water. We mainly used an old teapot, hose, copper tubing, 4-gallon container, 2 soft drink cans, and silicone to create a distillation system. This system failed since it took way too long to produce a significant amount of water by the 30-minute mark. Also, the coolant just increased in temperature over time, slowing down the production of distillate. From this model, we learned that the coolant needed to be changed from time to time to keep it at a temperature that will get the steam to condense. Also, we learned that the coil needed to be vertical. This model was not capable of holding the amount of water needed for distilling 1 liter of water, and it had to be sealed to work.
This prototype distiller was made with 2 pots and allowed for the coolant liquid to be removed more easily than before. Since water would not be available for cooling, soft drink was used as an alternative. Also, flour paste was used to seal the pots instead of silicone because it was easier to remove and clean afterwards. In this design, however, clean water was produced, but after a while the pressure built up, supposedly at the T-junction, resulting in the dirty water bubbling more violently and ending up passing through the hose, through the coil, and straight out into the collection container without being turned into steam. This pressure also resulted in one of the pots cover breaking the seal and popping open. This taught us that both hoses should not be connected to the same coil.